Density. What is density? Density is the amount of mass in a volume. It's usually represented by the units grams over milliliters or grams over centimeters cubed. Here's the formula to find density. Density equals mass over volume, or mass divided by volume. To avoid long, unending decimals for densities, remember to round them using the significant figures rounding rules from last week's class. Round to the lowest amount of significant figures from the starting numbers. Density is an intrinsic property of matter. It is characteristic to any specific element. This means that it is a measurement that does not change no matter how much or how little of the substance you have. It can also be used to identify unknown substances by comparing a measured density to known densities. Therefore, it can also be used to find mass or volume of a known substance as long as you have the other measure, mass or volume. With this formula for density come other density equations. The equation to find density can be manipulated. For example, the equation to find mass is volume times density, where the unit for mass is grams. The equation to find volume is mass divided by density, the units for volume being milliliters. To find the mass of something, this is very easy. Just place the item on a balance. In the lab, we have digital balances. Finding the volume can be tricky. This method is called water displacement. Water displacement uses a graduated cylinder to measure the volume change before and after adding an object in water. There's 3 steps to find volume through water displacement. First, you are going to put enough water into a graduated cylinder to cover an object. You will record this amount. Then you will place the object into the graduated cylinder and record the new water level. In the 3rd step, you are going to subtract the old water level from the new water level to find the volume of this object. Here's an example. Irene is working in the lab with an irregular object. She fills up a graduated cylinder to 20.5 milliliters with water and places the object in. The water level rises to 33.8 milliliters. What is the volume of this object? Very well. The new water level is 33.8, and we subtract to it the old water level, which was 20.5, to give us 13.3 milliliters. In another example, Ollie is trying to find the density of a rock. In order to find the volume, he fills a graduated cylinder with 15 mL of water and places the rock in. When he does, the water level rises to 22.6 milliliters. What is the volume of his rock? Very well, we take the new water level, which is 22.6, and subtract from it the old water level, which was 15.4, and obtain the difference, which is 7.2 milliliters, the volume of Ollie's rock. Now we will do some examples to find density. Kevin is working in the lab with an irregular shaped metal bar. He knows the mass of this metal is 43.5 grams. When he places the bar into 15.4 mL of water, the water level rises to 21.3 mL. What's the density of this metal bar? First, we have to find the volume by water displacement. We take the new water level, which is 21.3 milliliters, and subtract from it the old water level, which is 15.4 milliliters. We obtain the difference, which is 5.9 milliliters. This is the volume of the metal. Next, we take the mass and divide from it the volume. 43.55 grams was the defined mass, and from it we divide the volume which we've just calculated, 5.9 mils. We obtain 7.3813559 grams per mil. Our rounded answer is 7.4 grams per milliliter. Here's another example. Jen is working with a wooden block that has a mass of 5.33 grams. When she fills up a graduated cylinder to 14.5 milliliters and places the block in, the water level rises to 17.8 milliliters. What is the density of the wooden block? The volume of the block will be her new water level, which was 17.8 milliliters, and from it we take the difference from the old water level, which was 14.5 milliliters. The difference becomes 3.3 milliliters. This is the volume of her wooden block. The density of the block is the mass divided by this difference. 5.33 grams divided by 3.3 mils gives us 1.61515 repeating grams per mil. The rounded answer is 1.6 grams per mil.